Okay, let's continue from the question number 21. The first fundamental welfare theorem states that if agents act perfectly competitive and if every relevant good is traded at publicly known prices, then, we will read what the first fundamental welfare theorem says. If every relevant good is traded at publicly known prices, and if agents act perfectly competitive, then the market outcome is Pareto efficient for sure. Okay, so the outcome, the equilibrium, the final demands that the market gives us is Pareto efficient. Okay, then the competitive equilibrium is Pareto efficient. Yes, the competitive equilibrium is a good deal for the agents in the sense that no one can improve without worsening the other agent. Yes, this is the definition of Pareto efficient, yeah, of Pareto efficiency. The competitive equilibrium will correspond to with the idea of the invisible hand of Adam Smith. Yes, okay, the way the market acts, okay, without influencing in it, the forces of the market will carry us to a Pareto efficient outcome. Then, the second fundamental welfare theorem states that if agents act perfectly competitive, every relevant good is traded at publicly known prices, and agents' preferences are convex, then, let's know that this assumption is new. Okay, this assumption wasn't an assumption for the first fundamental welfare theorem. Okay, so be careful. The second fundamental welfare theorem states that if every relevant good is traded at publicly known prices, if agents act perfectly competitive, and if agents' preferences are convex, then any Pareto efficient outcome can be then achieved as a competitive equilibrium if appropriate feasible lump sum transfers or wealth are arranged. So, more or less, it says that the opposite direction of the first fundamental welfare theorem also holds. Okay, that the theorem holds in the other direction. It's not exactly that because of this assumption. Okay, so let's read the possible answers. Okay. The opposite implication of the first fundamental welfare theorem also holds. No, because it's not exactly that. Okay, any Pareto efficient outcome or allocation can be achieved as a competitive equilibrium. Yes. In the first welfare theorem, we say that any competitive equilibrium will be Pareto efficient. Now, what we say is that if we have a Pareto efficient allocation, that could be competitive equilibrium. This theorem states the same as the first fundamental welfare theorem, but with the additional assumption of convex preferences. Okay, so I would mark D. Okay, both B and C are correct. Well, now, 23rd. If the initial endowments of Natalia for wine and cheese are 15 and 9, and her final equilibrium demands are 14 and 11, then what about the equilibrium price? Okay, Natalia now has 1 unit less of wine and instead has 2 units more from cheese. Okay, he sacrifices 1 unit of wine for to get 2 units extra of cheese. So the price of wine is the double. Yeah, 1 wine costs 2 units of cheese, and as we set the second good as the numerator as giving it price 1, then it has price 2. Okay, then the equilibrium price ratio is 2. Okay, easy but important questions to understand how the trades are made in this general equilibrium. Okay. Question number 24. Lucia and Emma have the utility functions x squared times y squared, so 50% on each good of her income will spend Lucia, and Emma perfect complements. Yeah, perfect complements. For each unit of x, she likes to consume 2 units of y. Okay. Their initial endowments are 10.5 and 10.5. Okay, so 10 plus 10, there are 20 units of x supplied, and 5 plus 5, 10 units of y supplied. The contract curve is, okay, the contract curve when we have a perfect complement is just 2x equal to y, just equalizing these two components. So clearly we have C. Okay. Well, then 2010 the supplies, we have an edgework box like this, and the contract curve, this one, if we wanted to plot it, it would begin here, the 0, 0 for Emma, and then it goes until here. Yeah? When Emma has 5 units of x, she has 10 units of y. Okay, here. So her indifference curves, L-shaped, come this way, and the hyperbolic indifference curve for Lucia go up, go to the northeast, sorry, and well, they would give us these Pareto efficient allocations or contract curves we found. Now, Lucia and Emma from the previous exercise want to know which will the price ratio be. Okay, as always, we set price of y as 1, and then we can call the price of x p and interpret it as the price ratio. So we find the demands for Lucia with the usual formulas. So 1/2, because of the exponents, the budget of Lucia, 10 units of x, 5 units of y, divided by the price of x, here divided by the price of y. And now, demands for Emma. Well, we do the unit 1 exercise, yeah, the maximization of the utility of Emma subject to her budget constraint. Emma also has 10 units of x and 5 units of y. Then this is her budget, and this is her budget constraint. Then 2x equal to y, we substitute here, and we have pxe plus 2xe, yeah, 2xe equal to the budget. Then p plus 2 we take out as a common factor x, so at the end x is equal to this ratio. Okay, 10p plus 5 divided by p plus 2. Well, then if x is this, y will be the double. Okay, the double. And then we go, as in the Cobb-Douglas case, we go to the market clearing condition for y, and we find that the demand for Lucia plus the demand for Emma, yeah, here, the demand by Lucia plus the demand by Emma will need to be the total supply of good y, that is 10. Okay, so now we have to do these calculations. You know that in this case we always have a second degree polynomial, so we have the common denominator 2 times p plus 2. We operate it properly, and we at the end get second order equation. Then we have to solve it. We find two prices, one of them negative and the other one in this case is 0.2122. Okay, so this is the solution to this exercise, and that would mean that the slope of the price line is minus 0.2122, so quite flat. Yeah, quite flat. Going through the point W, we should know that the final equilibrium will be somewhere here. Okay, so Lucia should consume a lot of quantity of X and Emma few of them, and and of Y we can see that more or less we should have 3 units of Y for Lucia and about 7 for Emma. Okay, so we mark here 0.2122 here, and we go to the Walrasian equilibrium. I suppose is the next question. Yes, find the final demands. Okay, so we had the formulas of the demand from Lucia and from Emma. Yeah, from the previous exercise, we just had to substitute 0.2122, that was the price. We just substitute everywhere, and find these numbers. Are they logical? Are they correct? Or do they seem to be correct? Yes, because Lucia demands 16.78 from X, Emma 3.22 from X, and the sum is 20. Okay, that is the total supply, and the same for Y. Okay, the sum is 10. That were the total units of Y that were in the market. So at this point you can see that is more or less here. Okay, then perfect, we have done the Cobb-Douglas complement case. That is a little bit hard, especially to find the price ratio. Yeah. 27th, if the price ratio for a pure exchange is set over the equilibrium price. Well, this is a very important question for me. It would be much more important if we saw more complicated cases as perfect substitute, but anyway, you should understand this. Okay, if the price ratio for a pure exchange is set over the equilibrium price, assuming Y is the numerator, then we're saying that X is too expensive. Yeah, that X is too expensive. So if a good is too expensive, what do people do? Do they buy it? Well, no, they try to sell it. Yeah, when something is more expensive than issued, we try to sell it if we have units of them. So there will be an excess of supply of good X. Yes, it seems to be correct. Okay, well, but be careful, because this says any of the above could be true. There will be an excess of demand of good X. Of course not. Of course not. So, and the market will clear for good X. No, because there will be an excess of supply. People will demand fewer or less units of X than they are supplied. Okay, so very, very important question, this one. Okay, very important question, this, and the questions as this. Okay, similar to it. 28th, in which of the following cases the Edgeworth box will not be square? Okay, very easy, I hope. Well, 5 units of X plus 5 units of X, there are 10 units of X, and here 7 plus 7, 14 units of Y. So we don't have a square box in the A case. Yeah, and 7 plus 5, 12, 5 plus 7, 12. We have here in square case. Okay, the question was which one will not be square. So the first one, A1. Okay, this 5 plus 7, 12, and 5 plus 7, 12. Here plus 5 plus 7, 12, and 7 plus 5, 12. Okay, so the correct one is A. Very easy, but I think also it's important. Suppose there are two consumers, A and B, exchanging two goods, X and Y. Remand, we call W to the initial endowment allocations and E to the final demands at the Walrasian equilibrium. Which of the following is false? Okay, this is also very important because we have to know that if we trade, it's because we at least we stay the same. Okay, we would want to improve, but at least we stay the same. So consumer B will be better at the initial endowments allocations than consumer A. Well, this has no sense. This comparison is not important, and we do not need to know that. So it should be this, the false one. Okay, let's confirm that B, C, and D are true. Okay, the utility level of consumer A at the initial endowments, at the initial allocations, is less or equal than afterwards. Yes, because after the exchange we stay the same or we improve. Okay, the same for B, so this is also true, and D says that at least one of them will improve if there is an exchange. Yes, if there is an exchange, one of them should at least improve, leaving the other one the same. So A is the false one. Well, and let's do the 30th before doing a last break. In which of the following cases the Pareto set will not be generally a straight line? Okay, we should know that is the Cobb-Douglas case, because I've told you many times. Okay, so this is the case. Okay, when we have a perfect substitute Cobb-Douglas case, it's not easy to see. With calculations it's better, but we can see with calculations we can see that it's in a straight line. And of course, when we have perfect complements, the usual perfect complement, it's in a straight line. Okay, if we have a very strange complement, okay, strange things could happen, but okay, then we will make a little break and continue with the last 10 questions of these 40 questions. Okay.